Welcome back to another one of my applications of differentiation videos. We'll be talking about finding critical points, and this is my 5th video and probably my last unless anyone wants any more. But I've shown you really how to solve for them. You should have watched the previous ones because they go from easy stuff to harder stuff. But basically, I'm just going to give a run over here. Critical points, you need to find critical numbers, and then you sub them into the real function, to the original function, and if they come out defined, they're a critical point. If they come out undefined, they're not a critical point. Okay? To find a critical number, you either set the function to derivative to 0, or you set it to being undefined or not existing. Okay? So let's get on with critical points. So let's say example 1, function equals natural log squared x. Keep in mind that this is just another way of writing natural log x and then squaring it all. Okay, so now we're going to find the derivative. Well, you bring the 2 down, the inside the same, then you multiply by the derivative of the inside. Derivative of ln of x is 1 on x. That equals 2 ln x on x. Okay, now what we're going to do is we're going to set the derivative to 0, which we'll use to solve the top, and then we're going to set the derivative to undefined, which will help solve the bottom. So set the derivative equal to 0, which then will be 2 ln of x. Okay, so we divide both sides by 2, and we get that, because 2 divided by 2 is 1, and 0 divided by 2 is 0. So, and how do we get the x by itself? Well, we basically, I think e is the inverse of ln, but I'm not entirely sure that's the correct thing, so don't take my word for it. But take my word that to get x on its own, you basically just bring both of these to the power of e. So that'll be e to the power of 0 on this side, and e to the power of ln of x. Now, you look it up in the back of your textbooks if you don't believe me, but this here equals x, because the e and the ln cancel out, which basically just brings the x back down here. And the e to the 0, you type that into your calculator, you get 1. So our first critical number is x equals 1. Okay? Now, we set the derivative to being undefined. Does not exist. Which basically is the same as setting the bottom to 0. And the only thing on the bottom is x, therefore x is 0. Nothing to do there. Pretty easy. Okay? Therefore, our x value, our critical numbers so far are 0 and 1. So now we sub them back into the original function, and we find out if it's defined or not. So fx of 0 equals ln squared of, we'll start with 1. The function we sub in 1, ln squared of 1, that will equal 0. But let's spit out a number, so it's defined, it's within the domain. Whereas this one, 0, we sub in 0, we get ln squared of 0, and that does not exist, which means it's not defined. So even though we had 2 critical numbers, only one of them turned out to be a critical point. So, and that critical point, therefore, x equals 1 is a critical point. Alright, thanks for watching this video. It was pretty quick, but it didn't really need to be long, and if you've watched the other ones, you should have been up to speed with this sort of process. This is just to show you, I'm just adding an ln to change it up a bit, just from the plain x's and signs and whatnot. But anyway, thanks for watching. I hope you enjoyed this video, and I hope you have a good day.